Next, now, unit number 2, we want to calculate Fibonacci numbers mathematically. This time, mathematically. It's not easy, a lot of work. Okay? Yeah. But let's do it. Yeah. Yeah. All right. This number related to the golden ratio. So we need to start with the golden ratio. So I think you heard of that, right? Yeah, the golden ratio. Yes. There are many beautiful stories behind that golden ratio. Yeah. So once I saw a book about golden ratio, from the library, one small book, talk about all, brilliant stories about golden ratio. Now, here let's look at that number. How do we get that number? Golden ratio. Okay? Given a line segment. Okay? We want to split it into 2 smaller segments. We want to find a point to split it. So which point is the, most natural split point? Okay? Based on your criteria, right? So what is the criteria? Okay? About natural way to split, right? All right, so let's consider one point somewhere. Okay? So we get 2 smaller line segments, A and B. Now, one longer, one shorter. So let's take the ratio, the longer one over the shorter one. So we get a ratio. Okay? But, someone, so in ancient Greek history, so someone thought this ratio, when it equals the whole line segment A plus B over the longer one, A, then that's the most natural way. Okay? Yeah. So, because that's the, the best way to split. Okay? So they argue in that way. Yeah, in ancient history, ancient Greek history, okay, like that. All right, let's calculate this ratio. Suppose we have this relationship. How to find the ratio? A over B. Okay? Yeah. So it's a simple math problem. So let's solve it. Solve this equation. Okay? Yeah. In this equation, you have 2 unknowns, right? 2 unknowns. But you only have 1 equation. Okay? So it's very hard to find the values for A and B, but we can find for the ratio, A over B. We can find that ratio. Okay? So to find it, let's use another variable to represent this ratio. X equals that ratio. So we find X. Okay? Now, 2 variables become 1 variable. Yeah? A and B, now we use X represent A over B. So we only use 1 variable, X. See? Yeah. Now let's look at the right-hand side. A over A, that's 1. 1 plus B over A. Can we use X represent B over A? Yes, 1 over X. Okay? So 1 over X. So we get an equation with 1 variable. X equals 1 plus 1 over X. So this equation only 1 unknown, so we can solve it. Yeah, we can find the value of X. Okay? Yeah. So let's simplify that equation and solve it. Okay? Let's multiply X both sides to eliminate denominator. We get X squared equals X plus 1. Can you solve this equation? Quadratic equation. Quadratic equation. So, do you know how to solve it? Quadratic equation?
Or move x squared to the other side and make it all that equals 0.
Yeah. After that, how to solve? After we move to one side, is there? Good, good. You know the formula. I hope you know quadratic formula. Okay? You can still memorize that quadratic formula. Okay? All right. That's for the general case. But a not equal to 0. For the general case, we have this quadratic formula. Plus minus. Two solutions. Plus minus. Yeah, two possible solutions. Okay? We plug in ABC, right? ABC. Yeah, we get two solutions. But the minus one, you can see, if we use the second solution, 1 minus square root of 5, it's a negative number, right? Is the ratio can be negative number? No. So we should drop the negative solution. Negative solution, yeah? Because from our original problem, the ratio should be positive number. Okay? So we only keep the positive solution. And this number, square root of 5, approximately 1.618. This is the golden ratio. That's the famous golden ratio. That number. Yeah. Okay? Yeah. How to derive it? Yeah. So that's the whole procedure. Derive this golden ratio number. All right. Now the question, how can we relate this number, golden ratio, to Fibonacci numbers? That's very interesting, right? How can you relate that? Fibonacci numbers, we know they must be integers. They cannot be, fraction like that. The golden ratio, not integer. Okay? Irrational number. Irrational. Okay? Yeah. Square root of 5, irrational number. Okay? Yeah. So here we use a Greek letter phi to represent this golden ratio. Phi. Okay? Represent it. Yeah. All right. Because it's too long. Yeah. So we want a shorter notation for it. Phi. Okay? Like pi, right? Pi. You don't want to write 3.14, all the time. You just use pi. So here it's phi. Okay? Yeah. All right. Formula for Fibonacci numbers. Magic formula. Yeah. Yeah. Because it's hard to believe people can get this formula. It's really hard to believe. How can anyone find this formula? So that's why it's something like magic. Right? Yeah. So you will see the power of math. Yeah. From using math tools, we can find it. Okay? This is the formula, the magic formula. Square root of 5. Okay, 1 over parenthesis phi to the nth power minus this over, see? Yeah. Although not integer, but after you do all the calculation, you get an integer. How good it is. How good it is. Okay? Golden ratio and the Fibonacci numbers. That's the connection. Okay? Do you want to see why it is correct, right? Yeah. How do you know this formula is correct? Or how do you prove it? Right? So in math, if we already know something, if we want to verify it is correct, can we do it? Can we verify a formula is correct? How do we do it?
Could you substitute instead of equal to fn minus 1?
All right, so you substitute the value there. Then you try to, but right, you can write the expression, but how do you know that is the Fibonacci number? How do you know that number equals the Fibonacci number? Right? Yeah. Base cases. So we verify from the base cases, right? Yeah. We verify from the base cases. But how do you verify it is true for all n? Good. That's perfect answer. Perfect answer. Induction. Mathematical induction. So you can see here it is right situation, we need to use mathematical induction. Mathematical induction. The power. Okay? Yeah. But this time you can see, because golden ratio, it's not that easy to use mathematical induction. Okay? All right, let's see. Let's try it. Okay? All right. All right, so so let's see. Verification step. All right. Because it's a long story, it's a lot of work. Yeah. But we will do it. Yeah. So we will do it. Okay. All right.